Picture these. You're standing on a beach at night. Waves are moving around your feet. You look up, and there are two moons in the sky. One is familiar, pale, large, silver. The other is smaller, slightly reddish, sitting off to the side. It's a striking sight. But here's the catch. The water around your ankles is rising faster than it should, because in a world with two moons, the tides are nothing like ours. Coastal cities are built behind walls that dwarf anything we have today. Sailors and fishermen don't check a weather report. They check a dual lunar tidal forecast, tracking two overlapping cycles at once. The rhythm of daily life on Earth runs on a completely different clock. So what would actually happen if Earth had two moons? That's what we're working through today. To understand it, we first need to understand how we ended up with one. The most widely accepted explanation is called the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized body collided with the early Earth. The impact was enormous. It threw a massive cloud of debris into orbit, and over time that debris slowly came together to form the moon. The evidence for this comes from the composition of lunar rocks, studied extensively since the Apollo missions, and the hypothesis has been refined steadily over the decades since. What makes our moon unusual is its size. It's large relative to Earth, about 1/4 of our planet's diameter. That size matters. It drives our tides. It also stabilizes Earth's axial tilt, which keeps our seasons relatively consistent over long timescales. Now here's something worth knowing. Some planetary scientists have proposed that Earth may have had a second moon in the very early solar system. A 2011 paper in the journal Nature suggested that two bodies may have merged slowly over time, which could explain certain features of the moon's surface we still find puzzling today. That merger may have already happened. But what if it hadn't? What if that second moon was still up there? For this thought experiment, we'll assume a stable two-moon system. The original moon stays where it is. The second moon, which we'll simply call the companion, settles into a higher, slower orbit. Two moons, one Earth. What changes? Almost everything, as it turns out. Start with the tides. Our moon creates tides by pulling on Earth's oceans as it orbits. The sun contributes to. When the sun and moon align, we get higher tides. When they're at right angles, tides are calmer. This is basic tidal mechanics, and it already produces some dramatic effects. The Bay of Fundy in Canada sees tidal ranges of around 16 meters, the highest on Earth. Add a second gravitational body on its own independent orbital cycle, and the system gets far more complex. There would be moments when Earth, the moon, and the companion all align. During those windows, tidal forces would stack on top of each other. Tidal surges significantly beyond anything we currently experience would become predictable, recurring events rather than rare extremes. Coastal flooding wouldn't be an occasional disaster. It would be a scheduled one. The two moons would also interact gravitationally with each other. This creates what physicists call a three-body problem, a system where the motion of three objects under mutual gravity becomes extremely difficult to predict over long time scales. Some configurations would be stable for billions of years. Others might gradually drift toward a merger or an ejection. We're assuming the stable version here. But it's worth noting that this stability isn't guaranteed and would depend heavily on the specific sizes and orbital paths involved. The axial tilt question is where things get genuinely complicated. Our moon stabilizes Earth's tilt. Without it, models suggest our axial tilt could vary chaotically anywhere from nearly zero to very steep over millions of years. Mars, which has only tiny moons, wobbles on its axis significantly over geological times. Our moon keeps us from doing the same thing. That stability is part of why Earth's climate has been consistent enough for complex life to develop over hundreds of millions of years. A second moon would add another gravitational influence to that balance. It might reinforce stability, or it might shift the equilibrium point. Even a modest change in axial tilt from around 23 degrees to 27 or 28 degrees would intensify seasons noticeably. Winters colder, summers hotter, storms more extreme. Not catastrophic on its own, but significant across geological time. The night sky would look completely different too. Two moons cycling through independent phases would produce combinations we never see today. One moon full, one crescent, both half-lit at the same time. Overlapping shadows on the ground on certain nights, eclipse events, when one moon passes through Earth's shadow, or briefly through the shadow of the other, would happen more frequently and would have been among the most dramatic spectacles in the ancient sky. The calendar implications alone would have reshaped early civilization. Our word month comes from the moon's roughly 29.5-day cycle. Every early civilization used the moon to track time. A second moon on a different cycle would have made that far more complex. Do you follow the faster inner moon, the slower outer one? Some combined cycle. Ancient astronomers in Mesopotamia, Egypt, and China were already doing sophisticated calculations with one moon and 5 visible planets. Two moons would have made accurate timekeeping both more urgent and significantly harder. Regional calendar systems might never have converged. Different civilizations might have tracked fundamentally different cycles for thousands of years. Now let's think about what daily life would actually look like. Coastal cities as we know them probably wouldn't exist in their current forms. Places like Mumbai, Miami, Shanghai, and New York sit at sea level, or close to it. In a two-moon world, those locations would require either massive tidal infrastructure or they simply wouldn't have been built there at all. Major ports would need barrier systems and tidal gates as foundational civic engineering, not emergency additions. Cities built near water would be designed around water management from the beginning. This pressure might actually have accelerated engineering in some ways. Hydraulic infrastructure, seawalls, canals, tidal barriers, elevated foundations would have been essential survival technology rather than optional improvement. Civilizations that solved these problems would have had enormous advantages. Those that didn't would have faced recurring losses. The engineering incentive would have been constant and severe. Sailing and maritime trade would also operate on a different logic. Favorable tides wouldn't be a simple daily window. They'd require reading the intersection of two lunar cycles. A good day to sail in a two-moon world isn't just about wind. It's about which phase each moon is in and how their tidal forces are combining at that moment. This would have made oceanic navigation far more technically demanding, but it also might have pushed navigation science and astronomical observation forward much faster. There's a sleep angle here too. Research has found that human sleep patterns still show subtle synchronization with the lunar cycle. We tend to sleep slightly less in the days approaching a full moon, even in modern conditions with artificial light. Two asynchronous moons would create a more complex pattern of lunar brightness throughout the month. Whether that would train human biology toward more adaptable sleep rhythms or simply create ongoing disruption is genuinely an open question. It's the kind of thing that would take thousands of generations to know. The cultural and mythological impact would be deep. Nearly every ancient civilization gave the moon a name and a story. The moon represents cycles, time, tides, femininity, death, and renewal across cultures with no historical connection to each other. That consistency tells us something about how central the moon is to human experience. Two moons would almost certainly have produced paired two lunar deities, siblings, rivals, lovers, opposites, in some kind of celestial relationship. The moments when they appear close together in the sky or align for a supertide would carry enormous symbolic weight. Festivals, religious observances, agricultural calendars, all of it would have been built around the interplay of two cycles rather than one. The complexity alone would have driven astronomical record-keeping to a higher level of precision much earlier in history. Architecture would reflect the tidal reality too. When seawalls and flood barriers are necessary infrastructure, they become part of the visual language of a city. The aesthetic of civilization built alongside an aggressive sea would look different. Elevated structures, water-integrated design, infrastructure built to absorb tidal force. We're only beginning to develop this kind of design thinking now in response to sea level rise. In a two-moon world, it would have been the default mode for thousands of years. One more angle worth considering. Space exploration. When humanity eventually develops the ability to reach orbit, two moons would present a different kind of question. Which one do you go to first? The closer, more familiar inner moon, or the more distant, potentially more mysterious companion? The space race in our timeline had one obvious destination. In a two-moon world, that focused fragments, whether that would accelerate space development through competition or complicate it through division, is genuinely hard to say. Now, for the honest part, the geological consequences of a second moon would not all be manageable. Our moon doesn't just pull on the oceans, it creates what geologists call earth tides, very slight flexing of the crust itself. Research has explored possible links between lunar tidal stress and seismic trigger mechanisms. A second gravitational body, amplifying those stresses, would likely increase seismic activity in already active regions. Coastal populations facing higher tides would also face a more seismically active planet. That combination is genuinely difficult to adapt to, and it would have shaped where civilizations could safely settle in ways our history never had to account for. The biological story is just as significant. Intertidal zones, the shoreline ecosystems exposed between high and low tide, are among the most diverse on Earth. Many key evolutionary transitions, including the gradual movement of life from sea to land, happened in these environments. A more extreme and irregular tidal system would have shaped those transitions differently. Life would almost certainly have still emerged and diversified, but the specific path from ocean to land, and eventually to us, might have gone in completely different directions. What the dominant complex life forms would look like is impossible to say. The variables are simply too large, and that uncertainty is worth sitting with. We can trace the logic of tides, orbital mechanics, and evolutionary pressure. We can reason about how civilizations respond to physical constraints. But the further we push the thought experiment, the more we're working at the edge of what current science can actually model. Planetary scientists debate the long-term stability of two-moon systems. Evolutionary biologists debate the role of tidal environments in the origin of land life. These aren't settled questions. The thought experiment is valuable precisely because it reveals how much of what we take for granted, our seasons, our coastlines, our calendars, even our mythologies, traces back to one large rock orbiting us at a very particular distance. Change that one variable, and the ripples go everywhere. What's your take on it? Would a two-moon Earth have pushed civilization forward faster, or would the constant pressure of extreme tides and seismic activity have kept earlier societies locked in survival mode? It's a genuinely interesting question, and there's no obvious answer. Leave your thinking in the comments. If you found this interesting, there's more in this series. New topics go up regularly. Thanks for watching.